Okay, so what's this question about? This is to do with mixtures and particularly of liquids in a fuel. Okay, so what is the apparatus W on the figure above? So we can clearly see that distillation has taken place. You need to know the names of these particular things. So that's distillation, that's normal distillation. Okay. Fractional distillation, you will have this sort of thing called a fractioning column going up here, where it will be having different opportunities for different things different liquids to be tapped off. This piece of equipment here is called a Liebig condenser. When I say Liebig, it's Liebig, condenser. What is it? I hope I'm not going to get some random German person tell me it's a Liebig condenser or something. I don't know. No disrespect to the German people. Anyway, this one is your beaker here. Okay, so what is the apparatus W on this figure above known as? Okay, and this one is a round-bottomed flask. Okay, round-bottom flask. So we do that. Okay, what is the name of this method of separation? This is distillation. And name the changes of state taking place at A and B in the figure above. So if we look at A, what's happening is when you've got the Bunsen burner heating this up, what will happen is you'll get this liquid turning into a gas, which goes up there. And so that process will be boiling. And then what will happen is as it's coming through here, you've got running water surrounding this tube where the gas is going through, and this running water is cold and just surrounding that. So that bit in grey is the running water going in through the bottom and out through the top. And what you've got here is this is the bit where it condenses, turning from a gas to a liquid, and so that's condensing. That goes on at B. Table 1 states the boiling points of hydrocarbons in the fuel. Which hydrocarbon will be the last to collect in the beaker? Okay, so if we're doing distillation and we're doing this, the last to collect in the beaker would be the one that requires the highest boiling point. Think about this. It requires the highest boiling point to actually evaporate. It needs to be in there, it needs to be heated the longest, it needs to be in there the longest. So what is going to remain as in there the longest? It's going to be the one with the highest boiling point. That's octane. Yeah? And what you'll notice, in fact, this is a trend that you'll notice, the more carbons you've got in this longer chain, the higher the boiling point. That's a story for another day. The fuel is a mixture of liquids that has been designed as a useful product. What is the name given to this type of mixture? As soon as you see useful product and you know it's a mixture, think formulation. Yeah, that's what it is. Formulation. A fuel is probably, you've got your fuel, but you'll have loads of other stuff in there that just helps it to do its job. Okay. Describe how this fuel is different from crude oil. Okay, so how many marks is this? It's a 2-mark question. It means we've got to say something about the fuel and something about the crude oil. Okay, so how is it? The fuel is a pure substance. Okay, a pure compound. And crude oil is a mixture. Yeah, so that's what we'd say about those. Okay, and this one gives us a table. It says calculate the mean melting point of the hydrocarbon, leaving out any anomalous result. Okay, I cannot describe to you how many students struggle with this. It's when they say average or mean, they don't mean this is not math. This is not a maths test. Then you're never going to be asked for the mode. Yeah, you'll be asked for the range at some point, but when they say mean or average, you are talking about adding up the values and dividing them up by how many there are. Okay, how many values there are, and it tells you not to include the anomaly. So let's first identify the anomaly. What's the odd one out? Okay, so first trial was 35, second trial 48, third trial 37, fourth try 37. Okay, so you can see it's clearly out. The one is 48. 48 is clearly out. So we should ignore that. Okay, so that means we have 3 to work with, and you add those 3 and you divide it by 3 because we are using 3 values. So 35 plus 37 plus 37, and then you divide it by 3. It wants it to 2 significant figures, yeah, and you'll have the situation there. That's 36. So you would get 36.33 in your calculator. How do you convert as 2 significant figures? Well, you need to look at the number just after it, and decide to yourself, okay, what can I round that to make this to, the nearest 2 significant figures. So that's 6.33. You'd round that down 36. If it was 36.5, then you'd round that up to 37. If you want to know whether you've got the average correct, the average should be in between the highest and lowest result that you've actually done it. You've actually taken the averages of. So ignoring that, 35, 37, 37. Your average is going to be 36. Not because it's in the middle, okay? Because sometimes it could be different. But it must be between the highest and the lowest. That's the average. It must be at some point in between, yeah? So it's just a way to check that you've actually got the correct mean and you haven't missed out a value here or there. Just give it a quick scan by checking, is it between the highest and lowest value? If it is, well, hey,